Hocam, Miktat Hoca gelecek mi? Miktat Hoca. Gitti mi? Yok hayır. Hediye vermek için. Bir saniye. Zafer Hoca'nın hediyesini. Tamam. Sesini. Şimdi. Sayın katılımcılar. Sayın katılımcılar, programımız davetli konuşmacılarla devam etmektedir. Kanada'dan katılan davetli konuşmacımız Doktor Emine Ceren İyigüler yoğun program nedeniyle online olarak katılım sağlayacaktır. Şimdi onun videosunu yayınlayacağız.
Dear participants, our program continues with invited talks. We invite our guest speaker, Dr. Emine Ceren İyigüler. She's going to present her presentation online as a video due to her tight schedule. So we are going to show her presentation now.
Başlatalım. Gel. Şunu şey yapabilir miyiz? Ses açık değil mi?
I'm a postdoctoral researcher at the University Geophysical Observatory. Today we will briefly explore the space weather effects on aviation together. But first, I would like to thank the Sempozyum chair and the organization committee for inviting me as a speaker. Though I wasn't able to join in person, I'm happy to have the opportunity to talk about space weather with you. The structure of our talk is as follows. We will first talk about what space weather is and why it is important for aviation. Then we will have a look at past experiences and events and focus mostly on the radiation exposure of the cabin crew and mitigation of the space weather effects. We will finally end the talk with some takeaways, things that should be kept in mind when we think about how space weather affects the aviation operations. Space weather refers to the conditions on the sun and in the space environment that can impact technology on Earth and in orbit. Space weather is directly related to the solar activity level since Earth is constantly bombarded with the particles in the solar wind. The solar wind is the outflow of the solar corona, so we can basically say that we are living in the outer atmosphere of the sun. So this solar wind is always changing and varying, but sometimes there are also other things than particles which arrive to Earth. So the first one is the solar flares, which cause radio blackouts. These are primarily intense bursts of X-rays that can disrupt HF communications on the solid side of the Earth. And since these are X-rays, they arrive to Earth within 8 minutes. And then the second one is actually particles, which are known as the solar energetic particles. These create radiation storms on Earth, and these are mainly high-velocity particles that pose a radiation hazard to crew and avionics, and particularly on polar routes. These arrive to Earth within 10 minutes to hours. And then the third and the most popular one is the coronal mass ejections, which create geomagnetic storms. These are massive eruptions of plasma that disturb Earth's magnetic field, causing the most severe and widespread impacts to the ionosphere and GNSS. These are basically plasma bubbles which burst out of the sun with high density particles so they can shake all the magnetosphere and the currents within. And these arrive to Earth within 1 to 4 days depending on the velocity of the particles. So when there are solar activity related changes in the space environment like solar flares, the arrival of solar energetic particles or coronal mass ejections, we see some impacts in the nearer space environment, starting from the astronauts, like effects on astronauts, effects on satellites, down to the effects on the ground. But today, we will mainly focus on the effects in the commercial aviation altitudes. Actually, space weather is a systemic risk to aviation because the near Earth environment is ever-changing because of the solar activity. And the solar activity triggers disturbances that directly impair the technological infrastructure of modern aviation. For example, space weather can cause HF radio blackouts, which then would affect communication, of course, especially for the transoceanic and polar routes of the airplanes. And then, because of the effects of GNSS, there may be some problems with the route precision and landing guidance for airplanes. Also, there are some effects on surveillance radars, and elevated radiation exposure also poses health risks to crew and passengers on board. For example, on this slide, we see 4 major space weather events which led to operational responses from the airlines. For example, actually, the wide area augmentation system is used for improving GNSS accuracy for aviation purposes. But actually, during the 2001 geomagnetic storm, this model gave errors up to 10 meters. And for example, in 2003, there was this widespread service outage which forced flight restrictions. And actually gave the flag of not monitored for 15 plus hours. So that was a very big problem. Also, in 2012, there was a solar radiation storm which led to the disruption of high-altitude operations and forced rerouting of cross-polar flights due to HF communication uncertainty and unavailability. Also, very recently, in 2017, geomagnetic storm, there were really significant uncertainties and deviations need to be done for polar routes. And some airlines documented route deviations for the required flights. One of the major consequences was during Hurricane Irma in 2017. So Hurricane Irma actually devastated the Caribbean islands, but when there was this problem going on, a massive X9.3 solar flare also erupted from the sun. So remember that solar flares reach to Earth in 8 minutes. So after this arrival of the X-ray and solar flare, this caused an immediate severe radio blackout across the entire sunlit side of the Earth. And because the emergency responders actually rely on high-frequency radio, this band was rendered unusable for up to 8 hours. So because of that, for example, there was a report about a 90-minute loss of communication with a cargo plane to the region in need. And of course, there is the economic side of the things. For example, during the 2003 Halloween storms, because of the GNSS failures, due to the increased flight time and disrupted descent, there was this estimated additional cost of 2.43 million euros. And then extra fuel consumed per diverted flight was 12,000 kilograms. Also, because of the increased cosmic radiation exposure during the events, the potential economic cost of the diverted flights and cancellations was up to 48.97 million euros, which is a very huge amount. To understand the economical consequences and how large the impacts of a geomagnetic storm would be, we actually go back to the known events in the history. The first event to be recorded and the largest geomagnetic storm is the September 1859 event, which actually led the telegraphs to work without electricity. And telegraphs were the primary technology of the day, and actually there weren't much aviation operations, of course, and we weren't relying on technology that much, but even those could work without electricity. So this is what we use as the worst case scenario, and we call this event as a superstorm. And then there was this February 1956 radiation storm, and it is known as the most intense solar energetic particle event measured in the modern era. So this event actually showed that it caused 300-fold increase in radiation at 12 kilometers altitude. So that is actually the aviation operation altitude. So a single high latitude flight, like cross-polar flight, could have exposed air crew to their entire annual occupational dose limit. So there are actually two sources of cosmic radiation. One is the galactic cosmic rays. So these actually originate from outside the solar system, and the sources are thought to be supernova. These are constant, and those are mostly isotropic source of background radiation. So these particles can actually be swept by the solar wind. So the sun and the solar wind is actually protecting us like a shield from those kind of high energetic particles originating from outside the solar system. So because of that, galactic cosmic ray levels are actually highest during solar minimum because solar activity is the lowest. So sun does not protect us as it can during the solar maximum time. But then during the solar maximum time, there is another threat to the radiation, to the cabin crew, and to the space environment, and these are known as the solar energetic particles. So these actually originate from the sun, from solar flares and CMEs, and they cause sporadic, short-lived but high-intensity radiation events. And those are actually more frequent during solar maximum. So the impact is basically the HF communication blackout and the increased radiation exposure for the cabin crew. So to put the dose in context and to think about things more clearly, we need to know the dosages actually for average people. For example, for people like you and me, let's say that we don't go on flights that much. So the average dose, then the annual dose, would be 3 millisieverts. But then the average annual occupational dose for air crew is actually 3 millisieverts too. So if you are air crew and go on frequent flights, then you already receive a 6 millisievert annual dose, radiation dose. And then, for example, if you say that you are a polar red crew who is exposed to high radiation levels, then you may end up with actually to levels around 6 millisieverts. And the annual limit for radiation work is actually set to 20 millisieverts. So while well within regulatory limits for radiation workers, the average annual dose for air crew from cosmic radiation alone is comparable to average person's total dose from all background sources on the ground. So this is actually a lot to take in. This is why air crew dose levels should be actively monitored and managed. And actually there is this European Union action level, and it is set to 6 millisieverts. So actually the European Union legally requires air operators to organize work schedules and apply additional provisions for crew liable to receive more than 6 millisieverts per year. So this is also done by the Turkish Airlines in Turkey, and this has become the de facto global standard for triggering active dose management. But let's say that there is a pregnant person on board, then the radiation level actually, like the radiation threshold actually just decreases to 1 millisieverts, and it is thought of as a critical risk, because if you have a pregnant crew, a single event could cause the baby to exceed the recommended limit of 0.5 millisieverts in a single month. So the challenge is to be able to predict what is happening in real time and to be able to measure the solar energetic particles coming on an airplane. So in terms of the background and galactic cosmic rays, we are actually more successful because the galactic cosmic ray dosage is more related with the solar activity, the solar maximum level, solar minimum level, because the solar wind is able to sweep the galactic cosmic rays and shield us, as we talked about before. So actually the predictions from the models generally agree within plus minus 30 commercial altitudes. So we are doing a somewhat reasonably good job. But then if we talk about the very fast events happening on the sun, solar energetic particles and the storms that they create, that part needs improvement, because these can disagree by an order of magnitude, making them unsuitable for rapid, high confidence operational decisions. So this means that we have to have real-time measurements to be able to do some operational changes so that the air crew is not exposed to the elevated radiation dosage. So the high uncertainty in solar energetic particle forecasting means that we cannot rely on prediction alone, and the industry must shift focus to real-time measurement and adaptive mitigation. The first real-time mitigation during a geomagnetic storm actually happened last year during the Canal storm of NOAA scale G5, which is one of the most extreme geomagnetic storm levels. So during this storm, actually a flight was supposed to take off from San Francisco and land in Europe, following the high latitude Great Circle route shown here with this solid line, which is also the Quiet Day route in June 2025 for the same flight, for example. But then, because of the anticipated air traffic communication blackouts and elevated radiation levels, the airline's operational control center made a proactive decision to reroute the May 2024 flight away from the high-risk polar region. So they deviated the route to this orange dashed line seen here, which had a lower latitude, lower altitude path based on the space weather warnings. Actually, this proactive decision delivered a demonstrably safer outcome for the air crew, because you can see from here that the orange line, 79 microsieverts, were during the mitigated storm flight in May 2024, but then during a standard quiet day flight, transpolar flight, the received dosage is around 90 microsieverts. Of course, why we don't choose this mitigated storm flight during the quiet days, despite the increased levels, is that you need more fuel, and of course there is this additional cost. But then, during the events, just for the safety of the air crew, what was done was a lower latitude was chosen for higher magnetic shielding, and a lower altitude was chosen for shielding with increased atmospheric depth. And then there is this natural phenomena, like the storm's own magnetic cloud actually acted as a natural shield for Earth, reducing the influx of background galactic cosmic rays by 11%. So that the changes in all these three areas just led to the lowering of the radiation levels by 14%. In 2019, the International Civil Aviation Organization actually has established a global framework for providing space weather information by recognizing the operational risk due to space weather. So these consortia actually monitor phenomena and issue standardized advisory information 24/7 for the international aviation community. So though not shown here, Turkey also gets some information from the Pan-European Consortium, and sometimes the flights are diverted by following the advisories from this consortium. To summarize, we have seen that the space weather affects HF communications, GNSS quality, radiation levels, and the flights which have polar routes. So the current models are very good for galactic cosmic rays, but still uncertain for solar energetic particles, which requires the need to integrate space weather measurements and observations in the aviation meteorology. And also, the modern storms and the mitigation methods that were used during the May 2024 show the need for effectiveness. So thank you for listening, and if you have any questions, you can contact me from the email address you see here. Thanks again, and have a good symposium.
Doktor Emine Ceren İyigüler'e değerli sunumları için teşekkür ediyoruz. Sıradaki davetli konuşmacımız NATO'dan Profesör Doktor Rene Hayes'e katılım sağlayamadıklarını ve üzüntülerini dile getirdiler. Son olarak davetli konuşmacılarımızın son sırasında İstanbul Aydın Üniversitesi'nden Profesör Doktor Zafer Aslan yer almaktadır. Kendisini konuşmalarını yapmak üzere kürsüye davet ediyorum.
We thank Dr. Emine Ceren İyigüler for her valuable contribution. And our next speaker was going to be Rene Hayes, but he is not able to join our conference, and he just expressed their regrets to us. And now our next invited speaker, Professor Dr. Zafer Aslan from İstanbul Aydın University. So we are inviting her to the podium for her speech.
Thanks.
Dear colleagues, my distinguished advisor, Professor Rene, and the regional director of the Kartal, it's great, and our chair of all sessions, and all colleagues. It's a really great honor for me to get this chance. Thanks a lot for this invitation to our organizing committee. So here in this, here in this presentation, I shortly try to share with you some recent developments on atmospheric boundary layer and interactions with the new generation of the modeling. Indeed, we had already applied some gliding measuring system with the installed gliders 35 years ago. Now we use drones. So it was really great opportunity for having this technology. And atmospheric boundary layer, we know its important role, especially on the terrific, orographic and complex terrain. and some model results and some future work will be shared with you. So atmospheric boundary layer has an elevation differences up to the 1.5 kilometers. Of course, it changes along with the differences of latitudes. And short-term model prediction results are crucial for predicting atmospheric boundary layer conditions, especially some hybrid models in recent years. It's getting more and more popular. So here I would like to underline some opportunities put it forwarded by International Theoretical Physics Center by Dr. Kouachi, Spiti, and from Italy, and from German team, Top Term, and VRF, and ERA 5, and even national one, Hazarfan. So the season variations in cloud-based height and the role of climate change has a crucial role on flight path planning, not only for technically, but also economical point of view. So we had already started with the one-dimensional situations, and wavelet helps us to understand the different scale activities, and also in different seasons we can check these details. Early morning, Miktat Hocam and other colleagues underline the importance of the height of the boundary layer in different terrain conditions, let's say dry or urbanized or water surfaces, wet areas. So we have very complex and dynamic structure. And of course, air-sea-land interaction has a crucial role, and we have main source, solar. Fortunately, we have it. A couple of minutes ago, Jeren kindly explained all the details. Teleconnections from sun surface through the dome on the Earth's surface. So we had this energy sharing together with water surfaces, and ice surfaces, snow covers, and also in addition to the chlorofluorocarbons and other components of the atmosphere. Of course, energy budget has a crucial role, and we have here some basic, in general situations, in sharing variables from top to bottom and from bottom to top, even initialized from the sun surface to the deep ocean. And this is also explained, this slide explains the role of greenhouses and their role like as a blanket on the Earth's surfaces. So in recent years, we frequently heard about the big data. What is the big data? Indeed, we are too lucky because of the NATO projects we involve in this, for cube problems, solving these problems. And as you see here, some characteristics of the XYZ axis, you have some, vertical axis, sensible heat, and also in XY direction, north-south direction, and west-east directions. We have this sketch area, and of course, with this close-up image, we mesh all the details of the cube. So many years ago, I tried to simulate these bubbles in water tank together with Emrah Hocam from chemistry department here. We are very much obliged to him. And this is the very simple simulations of the pools, from the convergence layer to stabilize the boundary layer. And later on, we have some models and have some outputs related with the plants or thermals in the boundary layer, hot bubbles and warm, cold bubbles, blue and reddish color. And this is very well known in most of the boundary layer booklets. We have this structure, potential temperature and wind speed components, U and V components, and their variations through the upward. And this is the standard situation, but of course in complex situations it has too many effects. Even in free atmosphere, we have, if there's enough energy, we have the penetration through the stratosphere. And you have here some temperature profiles and wind speed profiles, and also different models like cylindric models or inverse cone models or thermal models. So we initiated these models during my PhD thesis, and we tried to compare the theoretical outputs with the real measurements, real flight measurements in Turkish Air League training school in İnönü, Eskişehir. So here it's really complex even. I don't want to spend, we know very well from the textbook, even in horizontal cross-sectional and vertical cross-sectional parts. But you know, Leonardo and they watch the bird's motions and they try to understand the basic dynamic structure here. So we also try to go, and first we met entrainment word, not entertainment, in 1985. So it was very new area for us, and then we try to understand very well for the bubbles and even dry or wet one. So here there is some aircraft observations. That time in University of Washington they have installed aircraft measuring systems, and Dr. Clark, they have their flights, specific private flights, belongs to the Washington University Atmospheric Science Departments in 1987. It was really great. But now we realize that together with the installed drones, we have vertical profiles and their measurements abilities. And here again, very strong events. Early morning, it was discussed from our colleagues, and squall lines and also microbursts. They have a crucial role on landing and land on and land off activities especially. Now here I just try to symbolize some of the CPD model outputs, because in recent years we have corresponded some of the economical groups. They worry about the economical point of view of the flight activities, especially the ticket prices. You know, it depends on the cloud-based and cloud top heights and also cloud cover. So it is great because we had already had some outputs to compare the climate changing effects on cloud cover variation by using SPEEDY program at ICTP, and we had some reference years, first term, second term, and the last term. So we realized that there is some efficient evidence of this variation. So of course, by helping of the three-dimensional climate model, we have this horizontal grids, and also we should consider the scale differences in vertical and horizontal meaning in time domain and in space domain. So we just started with, you know, small scales and thunders and density equations and even long wave variations. And also it shows some model outputs in 3D version. So here some details related with the SPEEDY programs. This is one kind of the parameterization organized in Dynamics Laboratory beginning from 1994. They tried to develop this model. Now it's version 41. And this is one of the prognostic model. And also there are 8 levels, and resolution and other details have been mentioned here. And what about the physical parameters associated with this program? First one is the convection. And the next one is the large-scale condensation, of course clouds, shortwave radiation, as Ceren mentioned about the importance factor of the solar energy, our main energy, sharing it, and long-wave radiation, fluxes, and vertical division. These are the basic physical parameters regarding with the SPEEDY running programs. And amongst these outputs, we just consider here, I just try to share with you some outputs related with the cloud cover for deep clouds, convective clouds, and from congested to very well developed thunder clouds, and also sensible heat fluxes as a unit of percentage and watt per square meter. As you see here in the first study term, we had some studies over northeastern part of Turkey. We have 85% as an average. Average is not so good value in statistics, but it gives some idea about the general trend of all kinds of the data. So we have here 85% cloud cover. Excuse me. And in the second term, if you look at again the northern Black Sea, it gets down 70. And if you look at the last term, it increases up to 85 again. So which means that if you have some flights from Batum to north or west or east, so which means that flight paths will be increased. economical point of view is here. And so if we look at here the sensible heat flux, they show the similar trends, and just very basically the statistical table explains the min max values for the cloud coverage here for the dynamic one, minimum and maximum range here from 25 up to 85 in the first term, in the second term from 40 to 70% of the cloud cover, and in last term it's increased up to 85. So these are very important regarding with the humidity originated from the sea surface, Black Sea. It is the main source of the cloud triggering mechanism, and so SST, sea surface temperature, is very important. Most of the recent studies have been carried out associated with the SST analysis and cloud base and cloud cover variations. So here we had some case studies together with my young colleagues at our university, Department of Computer Engineering. As you see, SST values show increasing trend and in near vicinity of the Mersin. So we use some satellite data, and here some metrics, and we use different data mining, advanced data mining models. They are single models, and we use Prophet LSTM and also autoregressive models. So we try to have some short-term prediction for the forthcoming period regarding with the SST analysis, and there is sufficient evidence of the model outputs. So here, regarding with our presentation today, I try to add some outputs related with the cloud base height. As you see here, there were some connection in between North Atlantic oscillations, which means probably teleconnection. So we have here general periodicity, and we have here also cloud base, and we have here 2 years cases, and we have here 2 years blue and purple, green and purple curves belongs to 2023 and 2024. So we need to extend our study. These are just very preliminary analysis of this meaning, and as you see here, cloud base is increased from, let's say, boundary layer into the boundary layer up to the 7 kilometers, and even in 2023, this part, it belongs to the winter term and early spring. And during the summer we have here, and during the late autumn we have here, and even 2024 we have nothing in the next part, as you see, such kinds of the probably periodicity. And wavelet X helps us on this meaning. We are too lucky because by helping of the one-dimensional wavelet, we have deeply understanding of the level by level, micro, meso, and large-scale events and their role on the signal. As you see here, the first one is the first graphic here. As you see, associated with the large-scale events, mesoscale events, and small-scale fluctuations and their role on cloud base. And if we look at the 1D continuous wavelet packets, the purple area are associated with the large-scale events and associated with the extremes. They explain the extremes of the cloud base. And even in the middle part of the studied term, we have here high periodicity and large-scale events. And later on, regarding with the highest clouds, we have here very high small-scale and mesoscale fluctuations. And these are the similar indicator associated with the North Atlantic oscillation. So we should extend these studies. And here is my prematura model. 35 years ago, we used Fortran, and we had an appointment from the Taşkışla, the big IBM machines. So we were waiting in the queue, and we would have some outputs. And I'm very much obliged to my supervisor. He is always with the patient and with the orientation. We had this. I'm also lucky because one of the colleagues, Jorgen Jensen, in US, in Washington University, he was studying the similar topics with his supervisor, Professor Marcia Baker. So they were also considering the mass transferring entrainment rate 0.3, he also had 0.3 entrainment rate in our application. So this was very small indicators, but we had nice simulations and apps regarding with the theoretical applications. What about the conclusion and future work? Of course, today we discuss about the aviation and aviation meteorology and dynamic models and hybrid advanced machine learning techniques, especially MELES models. These are very important and they will help us too much. And cloud-based and cloud type heights and cloud cover predictions, and of course, connection in between the SST, sea surface temperature. So optimization of the flight height and economical analysis, and of course, in addition to climate changing and North Atlantic Oceans oscillations and other details. So here there are some references, but I would like to spend some time here, a couple of minutes if you kindly let me. Unfortunately, we missed Dr. Rene here today. He always helps us in NATO projects, and our professor, my first supervisor, Professor Dalmas, we are very much obliged to him. Dr. Reinhardt, who is the head of German atmospheric sciences, and first OSTIV president. OSTIV means Organization of Scientific Vole, gliding organization. So I'm so lucky that I tried to chair all the math sections and scientific sections for many years. Now I'm in the board member, so in this meeting I'm especially very much thankful to my 3 colleagues probably. They joined, even 4 colleagues, Funda Hocam, Tuncay Hocam, Ahmet Hocam, and Hakkı Hocam. Is there anyone I miss to join with us, Ostiv? So I'm very much thankful to them. They always encourage, and Jansen is here, and Hindman, and Hocam, Süreyya Hocam, and Yurdanur Hocam. Yurdanur Hoca is the first board member of the Space Agency, National Space Agency in Turkey during the establishment stage. Now he's in Oxford. Unfortunately, he wouldn't be able to join with us. And our history here, and as you see, Hilmi Demirağ and Hazarpan. And Grabowski, he is in Ankara. He works with 3-dimensional convective clouds and their modeling. And also Bruno and John, they are newly appointed as a chair of the meteorological session, meteorological panel of OSTIV, and also our president, Rolf, and Sabiha Gökçen. I am so lucky that I met with him, I worked with him. She was the honor member of the young Turkish Scottish group. So I was not young at that time, but we were. So, and then here, Professor Wellington, he prepared a book about the meteorology for glider pilots. As you see from Wellington, unfortunately, most of them are passed. I am also very much obliged to Karsten. Süreyya Hocam will remember. He came here with his motoglider. Can you imagine? From Germany, in Önü, and we had some measurements together with the instrumented flight systems in 83, 84, and so on. So there are many colleagues here, and I'm sorry, probably I missed some of them, and Abdullah from Palestine. He was my young colleague. He is graduated now, and I'm very much thankful to him for his advanced machine learning applications. So thank you very much for your patience, and here is our future is in skies. Thanks again.
Profesör Doktor Zafer Aslan'a teşekkür ediyoruz. Teşekkür belgesi ve hediyesi için Doçent Doktor Emrah Özdemir'i sahneye davet ediyoruz.
Yıllarca Zafer Hocam'la birlikte sempozyumdan o sempozyuma, o ülkeden o ülkeye hep birlikte dolaştık. Yani benim ikinci eş danışmanım oldu kendisi. Önemli karar almamda her zaman sağ olsun 24 saat gece gündüz rahatsız edip o da hiç usanmadan benim yani sabır göstererek her zaman yanımda olmuştur. Birçok kazanımı onun sayesinde edindim. Yıllarca yaklaşık 13-15 yıldır birlikteyiz Zafer Hocam'la birlikte. Birçok konferansta hep hediyeleri, sertifikaları onun elinden aldım. Allah bugünü gösterdi. İlk defa ben ona hediye ve de bir sertifika verme imkanım oldu. Hepinizin önünde ona yeniden şükranlarımı ve teşekkürlerimi iletiyorum. Teşekkür ederim.
Böylece davetli konuşmalar bölümümüz tamamlanmıştır. Şimdi bütün davetli konuşmacılarımızı toplu fotoğraf çekimi için kürsüye davet ediyorum. Branda. Dışarıya davet ediyorum.
This concludes our invited speaker session, and we now invite all our guests to speakers and guests to the stage for a group photo just outside the building. Öğle yemeğini de yedim. Söylesene sesini çıkmayı.
Programımız 12.30 itibariyle öğle arasına girecektir. 14.30'da panel 1 ile devam edeceğiz.
Our program has entered the lunch break as of 12:30, and we will continue at 2:30 p.m. Thank you.
Ben oradan nasıl şey yapabilirim?
Buradan çekeceğim.
Buradan telefonum yanında değil.
Branda'nın orada resim çek. Tabii hocam.
Ay ya. Mesaj sesi geliyor.
Şunu kapatayım, ben bırakıyorum buraya, bunu öğleden sonra alacağım.
Tamam. Aynen, ben de bunu şey yapıyorum.